Hey everybody, this is a practical guide to Docker, Docker Swarm, and Jenkins. My name is James K. Smith and I will be your instructor for this course. So just as a quick intro, like I said, my name is James. I've worked in IT for 4 to 5 years. I have a variety of experience from front end to back end development. I've also done a lot of stuff in DevOps. I have worked for a variety of companies, from government entities to retailers to small startups. I've seen a wide variety of architecture, infrastructure, and deployment models. So hopefully that will help in any questions you may have about y'all's specific needs, and I will try to address those when you have them. Main goal. So main goal here is to build and manage an enterprise-worthy Docker cluster behemoth. So this is essentially something where you can deploy tons of applications, have them highly available, scale them up, scale them down, and make sure that they're completely load balanced. You'll be able to deploy these with the push of code. So you'll have a Git repo, and anytime something pushes to it, it will kick off a build that will test your code, that will then create a container and then deploy it to your cluster. So, and then we'll go over some ways to do alerting for your application if it were to, God forbid, go down or screw up. So we'll also look into ways to do hot fixes such as scaling on the fly, creating multiple instances using a front end GUI rather than doing everything through a Docker CLI. All right, so to get to a awesome Docker cluster, we really need to know why containers are awesome themselves. So first, what's a container? So a container is kind of like a VM, but it's not a VM. It's a walled off application within a single host, such as a VM or an actual Linux computer. So when you're inside this container, it really looks like a standalone Linux VM. It has its own bin directory, it has its own user space. It really feels like its own entity. And essentially, what you're doing with this container, what you would want to do with this container, is package everything you would need for your application. So it's the tightest package delivery from a environment perspective. So all of your libraries, such as all of your command line utilities that you would need if you needed curl, if you needed a specific version of Java, if you needed a specific version of of whatever. It didn't matter. Anything that you need, whatever you would need for your application to run, you would just need to make sure that it's packaged inside of your container. So to understand kind of why containers are a step in the right direction, we kind of need to know where we've been. So to know the most popular form of deployment and packaging was via fat jars and app servers. So you would essentially have an infrastructure layer that would have your racks of servers, and then you'd have a hypervisor layer that would contain that would have vSphere, that would be vSphere, and then you would use that to spin up VMs. And then on that VM, you would either deploy a fat jar or you'd have a web application server where you would deploy a simple jar and a WAR file. So this has been a great deployment mechanism as long as all your apps are very similar, like they're all using jar, they're all using an web application server to be deployed. But as you will learn in any type of company or no matter how big or small, you end up needing to add more apps, or add more services. And so usually you have some amount of constraint for cost, so you try and put multiple apps on the same VM. Eventually get to the point where all your apps aren't looking the same, and you're not going to be able to put all your apps on that same VM because of library conflicts, because of a need to do load balancing, because of a variety of reasons that you would need to spin up multiple VMs. You're hitting the max CPU, so you need to make sure that you create a new VM so to offload the application onto something with more availability. So you're doing a lot more thinking about where you're deploying to, and then you're not only thinking about where you're deploying to, but you have to make sure that that environment that you're deploying to, so the VM matches where what you've worked on in development. So you have to make sure all your environment VMs are as similar as possible, whether it's production or your local or staging or development. You have to work with your infrastructure team, or you have to work with your operations team to make sure that everything is exactly the way it is and that there's nothing mishandled, which doesn't always work perfectly. So, what's a better way? So, what's a better way? Obviously, it's containers, I wouldn't be doing this video. So, more specifically, Docker is what we're using. That's sort of the front runner for container creation and management at the moment. So it's definitely been the industry leader. Everybody's using it, from Google to Microsoft. Everybody's supporting Docker containers. So how does a container deployment model look, and why is it better? All right, so what we had before with 4 separate VMs that all had conflicting libraries and required their own VMs, you can now deploy all of those onto one VM using Docker. So within each container, I have all of the individual needs of that app. So if this one has Java 8 and this one has Java 7, that's all cool. It's all good. They won't conflict with each other. They don't even know that the other exists. They think they're the only thing running on this, and they only see what our container allows them to see of the environment. So you get a lot more flexibility from a developer's perspective on making sure that your container is perfect for the application that you need. And you know, because of the way the containers work, they're all packaged together as an image, that whenever you move this image from production, or from staging to production, or from development to staging, you know that you're going to have identical reactions from that container. As long as it has Docker, it should be able to handle the application in the exact same way. So that's sort of why the major benefit of moving to a container deployment model is that it's a lot easier to have the same look from your different life cycles, from staging to production, as you're in the same thing as your local. And then it also allows for you to not worry about whatever is installed on the VM, as long as Docker is installed. All right. So that leads us to our next thing, getting Docker installed.